In this lecture, I will discuss about backup overcurrent and earthfall protection of transformer. So here the transformer rating is 10 MVA 33 by 11 kV transformer. Okay. So 11 kV is the star side, and star side the star point is grounded, and for 33 kV side is a delta connected. Okay. So here the HB side CT and LB side CT has been shown, and it is connected to the 11 kV bus, and from 11 kV bus to feeder is taken. Okay. So feeder ratio for this feeder is 200 by 1, and feeder CT ratio for this feeder is 400 by 1. So here the overcurrent and earth fault relay is connected with this CT secondary circuit, and again from this feeder uh, CT secondary circuit overcurrent and earth fault relay is connected. 51 is the NC code for the non-directional overcurrent protection relay, and 58 is the non-directional earth fault relay. Okay. So in the LV side, 51 and 50N is connected from the CT secondary circuit, and from the HV CT secondary circuit, 51 is connected. Here the earth fault is not required because any earth fault occur in the 11 kV side, since it is a delta star connected, this earth fault will be converted in the overcurrent fault in the HV side. So in this video, I'll discuss about backup overcurrent and earth fault protection relay, and how does the backup overcurrent earth fault protection relay is coordinated with that of the feeder protection. Why it is called backup overcurrent and earth fault protection? Because it is a time delayed protection, and this overcurrent relay is coordinated with that of the feeder protection relay. Okay. Again, HV side overcurrent relay is coordinated with that of the downstream LV side overcurrent relay. That is why it is called backup overcurrent and earth fault protection relay. So for this feeder and this feeder, the current set for the overcurrent relay is equal to 1 ampere. Okay. And normally the curve which is taken for the overcurrent relay, that is the IC standard inverse for 3 seconds, where trip time T is equal to 0.14 into TMS divided by PSM to the power 0.02 minus 1, where PSM is the plug setting multiplier, which is given by the ratio of the fault current to the setting current. So here setting current in terms of secondary is 1 ampere. So in terms of primary it is 400 ampere, and in terms of primary for this feeder is 200 ampere. So we'll calculate the fault current considering the capacity of the transformer and percentage impedance. Okay. Then we will calculate the TMS for this feeder and this feeder. Okay. So in order to calculate the fault current very close zone to this 11 kV bus, but in this feeder. Okay. So fault occur at 11 kV bus or fault occur very close to this 11 kV feeder is almost same. Okay. So in order to calculate that, we have to know the full load current of the LV side. So full load current in the LV side is given by the 10 into 1000 divided by root 3 into 11, which comes as 525 ampere. That is the full load current. And HV side, the full load current is equal to 175 ampere. So neglecting the source impedance, we can calculate the fault current in the LV side, which is equal to full load current divided by percentage impedance. Here the percentage impedance is 8%. So we'll get the value of the fault current is equal to 525 divided by 0.08, which is equal to 6563 ampere. Okay. So we'll calculate the value of the TMS considering this fault current, and considering that 11 kV feeder to be tripped within 150 milliseconds for closed zone fault. So the plug setting multiplier for this feeder will be fault current divided by relay setting current, which is equal to 6563 divided by 200, which is equal to 32.8. Okay. So trip time T is equal to 0.15 is equal to 0.14 into TMS divided by 32.8 to the power 0.02 minus 1. So value of the TMS comes as 0.077 second. Okay. Again, for this feeder, the TMS would be same as the CT ratio is 400 by 1. So the TMS will be somehow different from this feeder. Okay. So here the PSM is equal to 6563 divided by 400, which comes as 16.4. So as the trip time is 150 milliseconds, so 0.15 is equal to 0.14 into TMS divided by 16.4 to the power 0.02 minus 1, which comes as TMS is equal to 0.062. So in order to trip both this feeder within 150 millisecond, if closed zone fault occur, if either of this feeder or this feeder, the TMS of this feeder for current set at 1 ampere will be 0.00077 second, and TMS for this feeder is equal to 0.062 second. Okay. Now I will calculate the TMS for this LV side of the transformer. So since the LV side full load current is 525 ampere, the current set for the relay, that is the overcurrent relay, is given as the 10% of the full load current. So here the current set for the feeder would be 525 into 110%, which is equal to 578 ampere. So relay setting current is known. Now we'll calculate the TMS by considering that 11 kV feeder to be tripped within 150 millisecond for closed zone feeder. So 100 millisecond margin is given for 11 kV side of the transformer overcurrent relay. Okay. So first priority should be given that 11 kV feeder relay first trip the circuit breaker. If it is unable to clear this fault, then 100 millisecond is margin is given, then this relay will trip the bus. Okay, trip the bus means it is trip the circuit breaker of LV side, and that is why this fault will be cleared. So here the trip time is 150 plus 100 is equal to 250 millisecond. So we know the value of the PSM for very closed zone fault. So fault current is 6563 ampere, and the setting current is 578 ampere. So PSM comes as 11.35. So the trip time T is equal to 0.25 is equal to 0.14 into TMS divided by 11.35 to the power 0.02 minus 1. So value of the TMS comes as 0.089, or it can be set as 0.09 second. Okay. So this is how the LV side overcurrent relay TMS is chosen. Now, if fault occur very close zone to this feeder or 11 kV bus, the fault current will be 6563 ampere. Okay. So the priority should be given for trip of this feeder, then LV side of the transformer. Again, 100 millisecond margin is given for the tripping of this HV side breaker. So 150 plus 100 plus 100 is equal to 350 millisecond time is given for the HV side breaker to be tripped. Okay. So by means of that, we will calculate the TMS setting for the HV side overcurrent relay. So plug setting multiplier, that is the ratio of the fault current and current setting, should be same as that of the LV side overcurrent relay, because the fault current will remain same and the relay setting current will be 110% of the full load current. So the trip time T is equal to 0.14 into TMS divided by 11.35 to the power 0.02 minus 1, which is equal to 0.35. So value of the TMS comes as 0.125 second. Okay. So this is how the TMS value is calculated for overcurrent relay, and it is coordinated with that of the 11 kV feeder and downstream side of the transformer. Okay. So now I will calculate the TMS setting for the earth fault relay for the 11 kV feeder and LV side of the transformer. Again, it is a delta star connected, so any earth fault occur in the LV side, which will convert in the HV side as a overcurrent current, and that is why the earth fault in the HV side should be disabled. since it is a delta side in the 33 kV side. Okay. So considering that the source impedance is negligible and the fault current is same with that of the three-phase overcurrent current, that is the earth fault current is 6563 ampere. So current set for this earth fault relay is 40 ampere, that is set at 20% of the secondary rated current rating. So here's the CT ratio is 200 by 1. So I set is equal to 20% of 200 by 1 is equal to 40 ampere in terms of primary setting or 0.2 ampere in terms of secondary setting. So PSM comes as 6563 divided by 40, which is equal to 164 ampere. 164. So consider that the feeder to be tripped within 150 milliseconds for closed zone fault. So trip time T is equal to 0.14 into TMS divided by 164 to the power 0.02 minus 1. Since T is equal to 0.15, the value of the TMS comes as 0.115 second. Again, for this feeder, it is set as 20% of this CT ratio of the rated current. So in terms of primary, it is 880 ampere, or in terms of secondary, it is 0.2 ampere. So here the PSM is equal to fault current divided by relay setting current, that is equal to 6563 divided by 80, which comes as 82. So here the trip time T is equal to 0.15 is equal to 0.14 into TMS divided by 82 to the power 0.02 minus 1. So TMS comes as 0.0987 second or 0.1. So a 100 millisecond margin is given for the setting of the earth fault relay TMS for this LV side of the transformer. So again, the current set as a 20% of the rated current, that is I said is equal to 120 ampere, as the CT ratio is 600 by 1 or 0.2 ampere in terms of secondary current. So the PSM is equal to, for this relay, is equal to 6563 divided by 120, which is equal to 54.7. So considering that 150 millisecond plus 100 millisecond margin, that is the trip time is equal to, for LV side of the transformer, is equal to 250 milliseconds. So trip time T is equal to 0.25 is equal to 0.14 into TMS divided by 55 to the power 0.02 minus 1. So we'll get the value of the TMS as 0.15 second. Okay, so this is how the TMS of the overcurrent and hot fault relay is calculated. Again, for this calculation, we have neglected the source impedance and we have assumed that three-phase overcurrent current is fault current is equal with that of the single phase to earth fault current.